Okay, so just in this video, I'm going to show you how you can use the initial state calculator to compare two different grids and the volumes that fall within them. So the initial state calculator is obviously, by its name, its primary intention is to be used to assist you with your initial state. But in this example, what I'm going to do is I've just got two basic grids here. I'm going to show you how we can use the tool essentially twice, the initial state calculator twice, to scan the solids across the two grids and compare the two. So the first thing you're going to absolutely need is, depending on the number of solid types that you've got, so in my example I have both waste solids and coal solids, but for each solid type that you have, you'll need a percentage type field. So in this example here, I have scan 1, scan 2, and what I've got is a different percentage type field for my waste and for my coal. And you can see I've got a second scan folder with waste percent and coal percent. Now I'm collecting how much of it is above the scan. You can collect how much of it is below the scan. It doesn't really matter. The process is effectively the same. And then I'll come back to these volume fields and this scan difference field. But for the moment, you just need to have a percentage field for each solid type that you have. So I have two solid types, so I have two scan fields. And then under the utilities, I have initial state calculator. You can access it from elsewhere, but for this, it's simplest to grab it from the table that you're interested in scanning. So on this screen, what you want to do, if you've got other solids that you have in your table, don't worry about them. What we're interested in are your visualization solids. In particular, in my example, I've got imported waste and coal. You may have them elsewhere, but most importantly, it's really the solids that you want to scan. And for each of those, what you're going to need to do is click on them in this tree list and then set an initial state field. So we're going to be doing this twice. For the first pass, I'm going to be setting waste to scan 1 waste and coal to scan 1 coal. Now I've set my resolution to 10 meters because at 20 I miss a couple of solids, but the lower this number is, the more highly detailed your scan will be, but the slower it will be. The rest of the settings aren't super important. I would suggest leaving everything else for the most part at the default values if what you're looking for is a volumetric comparison. So if anything's greater than 95%, we're just going to assume that it's 100%, and if anything's less than 5%, we're going to assume that it's not there at all. Now, the only other behavior that you might want to touch is the empty scan behavior. So if the solid is totally missed by the scan, if you assume that it's, or if you ignore it or assume that it's entirely below both of those options in this example, you'll set as a number of 0. So you may not want to do that. You may want to set the number as 1, in which case you'd assume the solid is entirely above. What this setting means, remove above surface, it means that if a solid is 100% above the surface, remove means set the percentage to 100. So if you miss it, do you either set it to 0, which is what these two options will do, or do you set it to 1? So it's up to you how you want to treat the scans that are missed by the ones that will miss the grid or triangulation that you have. So once again, the only really important thing you have to do here, bare minimum, is also turn on which grid you're going to scan or which triangulation you're going to scan. So on my first pass, I'm scanning grid A into scan 1. Hit next. And what this has done is it's written for any individual record. We'll take one that's split down the middle. So we're at the 105. You can see that it's about, on scan 1, that's 100%. That's not the 105, it's not the one I was after. Oh, sorry, grid A is this one. So let's pick this record here. So you can see that it's found that it is 87.5% above the grid. So if we isolated that record in the animation, not with that one, with this one, you can visually ID that 85%. It's about right. I mean, that's the whole purpose of the maths, is to take away the guessing for you. So I've created a range to visualize what is under grid A. except I've renamed a few things, so this is not going to work. Scan 1 waste. I'll fix this one as well while I'm at it. Now this is a range designed to show me what is underneath the grid. So that's the result that I've gotten from the scan. The inverse of that, as you can see, I've got a couple of tiny little solids that, because they're so small, they actually got missed by the scan. So if I set the number to less than 10 meters, I'll probably catch those in the scan as well. So with this, I've got the first scan. I run the same process a second time. So initial state calculator, switch the grid that I'm scanning to the second grid, and switch the scan location to the second scan location. So coal goes to coal, waste goes to waste, except this time it's for scan 2. And the result of that. Now at the moment I'm just showing anything that sits 100% underneath the grid. You can see a couple of these catch the edges, but because of that 95% tolerance, they're being treated as 100% underneath the grid. But now pretty much once I've got these numbers, I can just use calculated fields to adjust the values based on the scan that was above. So originally in this 60, this record I showed before, I had 2,400. 87.5%, I've now got 2,140. So pretty much from then on out, it's just using calculated fields to compare the two numbers. So if you wanted to visualize what falls between one and not the other, you could do so with a scan, a separate scan again. So you could say in between or in between grids. And what you could do is put in a in range. I'll use the right click menu. That it is in range grid B. In range grid B. It's probably not the way that I want to do it because I can't combine an in range and a not in range. Might take this one. And use this as my in between. Sorry, I wanted to, so we'll take that and then we'll go not in range grid A. So that's saying give me material that meets the conditions of the first grid, but don't give me material that meets the conditions of the second. I thought I could get away with not having an expression filter, but it wouldn't work. So that's a way to visualize the data, and there's multiple ways of going about that. And then all I've got here is the difference between the two. So each of these records is just the waste volume above from the scan 1, subtracting the waste from the scan 2, and giving me my difference. How you want to use those numbers is up to you, but that's pretty much the basics. I mean, I've gone into a little bit more detail than I'd intended. Pretty much just the detail of it is every solid that you have, you want to have a percentage type field for the number of different scans that you want to do. So I wanted 2 scans and I have 2 different solid types. So I ended up with 4 percentage type fields that I needed to use to make that happen. And then I just used basic calculated field, multiply the original volume by the scan amount and use the numbers from there. So that's pretty much it. I hope that was useful.